Vision questions are the solving questions, the free response question. So for the part of the free response questions that require calculations, clearly show the method used and the steps involved in arriving at your answer. You must show your work to receive credit for your answer. Examples and equations may be included in your answers when appropriate. So let's begin with this question. HCl and NaOH and ACl and H2O. That's a neutralization equation between a strong acid and a strong base. A student was given the task of titrating 20 milliliter of a strong acid with a 0.1 molar of a strong base. The HCl was placed in an Erlenmeyer flask along with 2 drops of appropriate indicator. So here's the acid, HCl and an indicator, and above it there's in the burette I added the NaOH. We're doing a titration. An equation for the reaction that occurs in the titration is given above. According to the equation for the reaction, if the number of moles of reactant is halved, so if I started with less quantity of HCl, how does this affect the number of moles produced in the reaction? This is a simple question. If I started with less HCl, I'm gonna need less NaOH, I'm gonna get less NaCl and less H2O. So if it's halved, then definitely the moles of H2O produced will be halved. The equation above, which is this one, is not written in the net ionic form. It means it's not written showing the ions involved. Write the correct net ionic equation. So in HCl, the important factor is the H plus, and in the NaOH, the important factor is the OH minus. Of course, when you write an equation, always include the physical states. Now, this is a strong reaction, a reaction between strong acid and strong base, so it is going to produce H2O liquid. We remove the NaCl because it's coming from the spectator ions. In the equation you wrote in part B, which species is a proton acceptor? In other words, they are asking you which one is the base. A proton acceptor is a Lowry Bronsted base. So the proton acceptor over here is the OH minus species. How many moles of HCl are in 20 milliliter of a 0.10 molar HCl? Molarity is the number of moles over the volume per liter. So 0.10 molar is the number of moles they are asking about over the volume that has to be in liter, which is 20 times 10 to the power negative 3. So the answer is 2.0. When we do the calculations, it's 2.0 times 10 to the power negative 3 mole. Before I started this video, I removed the parts that are not included in your quiz and the parts that are gonna come later in the coming lessons. Now, the student performs a second titration using a 0.10 molar concentration of NaOH solution against as a titrant, but this time, so we didn't change the concentration of NaOH, but we changed the concentration of HCl. So I'll show you again. We had a 20 milliliter of HCl, but their concentration was 0.10. Now I have the same amount, but as a higher concentration instead of 0.1. Okay, so the question is the box below. So we doubled the quantity of HCl that we started with. The box below to the left represents ions in a certain volume of a 0.10 molar HCl. In the box below to the right, Draw a representation of ions of the same 0.20. So since we doubled the quantity, you're just gonna double the figure. Do not include any water. So here we go. This is the Cl minus and this is the H plus. So just count. You have 4 H plus. So now you're gonna draw 8 H plus. 2, 3, 4, 5, 6, 7, and 8. And since you have 4 Cl minus, you're gonna do 8. 3, 4, 5, 6, 7, 8. Next, G, I removed it, not included in our lesson yet. Later on it will come. The student made observations related to the content of the Erlenmeyer flask. I remind you that first we had a solution of HCl in the conical flask, just like the titration of apple juice and sodium hydroxide that you did. So in the Erlenmeyer flask, we're talking about this one over here. Identify an observation that could have led the student to conclude that a chemical change took place during a titration. What is the observation? A color change is an observation, a change in temperature, bubbles, fizzing, all of these are indications of a chemical change. Now you stop the titration when the color changes. So the color change is an indication that there is a chemical change. Or also the reaction of HCl and NaOH is an exothermic reaction. So the temperature slightly increase. The temperature increase. So you may write also the temperature changed or increased. Moving on, another question. Again, this part is always written in AP that you have to show your answer and formulas and correct explanation. Answer the following questions related to HF and the titrant of HF. So I am titrating HF with a basic solution. In the following box, draw the complete Lewis dot diagram. Sorry, I forgot to remove this. This is not included, but you know this from before. So here's the H, here's the F, and this is the formula of HF, Lewis diagram, Lewis structure of HF. There's a single bond between them and lone pairs surrounding F. Now, they're showing you the reaction of the acid with the base. A student performed the titration of HF with NaOH. This is a weak acid with a strong base, just like the titration of apple juice with sodium hydroxide that you did, except that this time they're talking about a weak acid, HF, and not apple juice. The net ionic equation is shown above. Identify both the Bronsted-lowry conjugate acid-base pair in the neutralization reaction above. For each pair, who's the acid, who's the base. So this is the pair. So HF, F minus, that's the acid, that's the conjugate base. And that's the other pair, that's the base, and that's the conjugate acid. So clearly in your answer indicate which one is the acid, etc. using sentence. In terms of the species in the reaction, explain what occurs during the reaction that identifies it as an acid-base reaction. So here in this question, you just have to tell why HF is the acid, why OH minus is the base. So use the Bronsted-lowry definition. So HF donates a proton to OH minus. HF, just describe it, to become F minus, and OH minus becomes H2O. That's it. Or you can say OH minus is a proton acceptor, so it accepts an H plus from the HF, so that OH minus becomes H2O and HF becomes F minus. Describe this equation in words. The equation can be written in particulate form. Using the following key, draw the correct products above their formula. So here, they are telling you that this is H and this is F. This is O and this is H. Okay, so here this is F minus. So that's F minus. And this portion is gonna join this one. So this is H2O and these are the hydrogens. Okay, you can draw the black with or without the minus, because in the key they're not representing this as a minus, so it's okay just to do it like that. Moving on, a student titrated 30 milliliter of this weak acid with a 0.30 molar of NaOH. The results are plotted on the following graph. How many moles of HF are in 30 milliliter of 0.15 HF? So this is a simple question. Again, molarity is the mole multiplied by the volume. Since the molarity is 0.15, how many moles? And of course the volume must be changed into liter. So the answer is 4.5 times 10 to the power negative 3 moles. I removed F and G since we didn't cover these questions in our lesson yet. Question 36. Again, this is always the same sentence that you must include your answers with the proper explanation, etc. So here I have a weak acid that is ionizing to produce H3O plus and the conjugate base Ka is showing that this is a weak acid, also the arrows over here. Now the question says methanoic acid ionizes partially according to the equation above. The question says write the expression of Ka. Simply, Ka is the concentration of the conjugate base of methanoic acid multiplied by H3O plus or H plus if you want, but you can write H3O plus because it's indicated like that in the formula, over HCOOH. That's it. That's A. Calculate the pH of 0.25 molar of HCOO minus. Now, this is a free response question, so you cannot use the fast method. You have to include an ICE table, which I am going to do over here. So you write again the equation HCOOH plus H2O, H3O plus, and HCOO minus. Now, initially, change equilibrium, just like I taught you in class. You put here the original concentration. I don't have from those. Now minus X consumed plus X, and at the change I have minus X, X, and X. Then you proceed and you write the formula of Ka. Ka is equal to H3O plus times HCOO minus over HCOOH, so use the values X times X, that's an X square. And now here you look at the Ka, which is 1.8 times 10 to the power negative 4. So you have to write your assumption. Assume X is small, okay? And then you prove your assumption by dividing the original concentration over the Ka value, which is 1.8, times 10 to the power negative 4. So with this assumption, you are going to get 1.8 negative 4, a number that is extremely large, bigger than 500. So you will say assumption is valid, and you rewrite again Ka formula without the minus x down there. Now, let's continue to solve on this side. Substitute with the value of Ka, 1.8 times 10 to the power negative 4 equal x squared over 0.25. X squared would be these two values together. It would be 6.7 times 10 to the power negative 3 molar. Now, x squared is the concentration of H3O plus. Therefore, they want the pH. So therefore, pH is minus log the x, and it is equal to 2.17. So in the question, this one, your steps has to be clear. Now moving on. In the box below, complete Lewis dot diagram of HCOOH. Show all the bonding and the non-bonding valence electron. I didn't remove this question because you already took it last year. So there are lone pairs and a double bond with the O. But I'm not going to include this question in your quiz. However, I didn't remove it because this is something that you know. Now, moving on. Here I have a base that is ionizing, and here's the Kb. In aqueous solution, the compound H2 and NH2 reacts according to the equation above. 50 milliliter of this base is combined with 50 milliliter of another weak acid. So here in this equation, they're just showing us that this is a weak base that ionizes. But then they told us we added this to this one. Write the balanced net ionic equation for the reaction occurs between this and this one. So these are two weak acid and a weak base. The purpose of this question is to see if the student knows how to move the H plus from the acid and give it to the base. So HCOOH, we're always talking about a weak. Now these two are weak, but they're gonna react together, but they are stronger than whatever base and acid conjugates that we are going to obtain. So since this is the base, it's going to accept this H from this one. That's the acid. So H2, N. Now instead of 2 hydrogens, it's going to become 3 with a positive. And HCOO minus, that's the conjugate base. Don't forget to put the physical states. Is the resulting solution acidic or basic or neutral? Justify your answer. Now, we need to see if who's stronger in this case. Let's go back to compare the Kas of the given acid and the Kb of the given base. So I'm gonna write them over here. I'm gonna erase this space so that I can put my answer over here. So I have an acid that has a Ka of 1.8 times 10 negative 4 that reacted with a base. The Ka and the Kb, I can compare them because Ka and Kb shows the extent of the ionization, the degree at the extent to which HCOH and H2 and H2 ionize. So I can see their values and say who's stronger than which one. Okay, so in this question, who's more? This is a strong, wait, -6. So here I have -4 and here I have -6. So definitely the acid is stronger than this base. So the correct answer here would be the resulting solution is acidic. What did you do? You just compared Ka to Kb. So you will say because the Ka of the acid is larger than the Kb of the base. So it is an acid. Next, I can also compare the Ka of this and see the Ka of this one and the Kb of this one, but it's gonna be the same result. So simply compare the Kas from the beginning, okay? Or yeah, so here the Ka is larger, which means I'm gonna explain it also just like the answer key so that you will understand. This is a stronger acid, so it's gonna produce a weaker base. So the Kb of COO minus is gonna be less than the Ka of the conjugate of this one. So I hope I'm not confusing you. I'm gonna repeat. So Ka of HCOOH is more than the Kb of H2NNH2. Now, the conjugate base of HCOO minus is gonna have a Kb. So the conjugate base HCOO minus is gonna be less than the conjugate acid in terms of strength of this one. So I hope now that is clear. Okay, so for this reason, the solution is acidic. Moving on, when a catalyst is added to a solution of HCOH, the reaction is represented by the following equation. HCOH, H2 and CO. Okay. Is this reaction redox? So I am excluding this from the question. Now let's move on. After also this one, after the reaction has proceeded for several minutes, does the amount of catalyst increase, decrease, or remain the same? A catalyst does not affect the amount of products obtained. Always a catalyst makes the reaction faster. So it would remain the same. It's just that we will obtain the product faster. Finally, the last question in the free responses, we have a solution X of a strong base mixed with a strong acid, equal amounts. So which makes X a neutral one. Solution Y is made of a salt, a neutral salt, Na plus and Br minus, because they are coming from strong acid from Na plus Br minus. I don't want to confuse you more than that, with a strong acid. So this is neutral and this is a strong acid. For the other one, I have a weak acid with a weak base, with its own conjugate. This is buffer, it's coming later, but we can still deal with the question. A student prepares the 3 solutions as described in the table above. The values of Ka of the acidic species in the solution are given. Here they're helping you to know that HBr is a strong acid and this one is a weak acid. Using the information above, write the three letters of the solutions means X, Y, Z in the box below to rank these solutions in order of increasing pH. Which one is the strongest acid? This one. It will have the lowest pH. And this is a neutral one. Now, this one, it's neutral, so the pH at 25 Celsius would be not acidic, neutral. Now for the solution of Z. This is an acid, well actually this is a buffer. From the Ka, I can calculate the pKa. When I calculate the pKa value is gonna give me an idea about the nature of this solution to say if it's acidic or basic. So minus log 1.8 is a 4.74. So that is a buffer. We will take buffer later on. But from the value, you can understand that solution Z is a weak acid. So definitely it's gonna have a pH less than the neutral solution X. Moving on to DB, does the pH of solution Y increase, decrease, or remain the same when water is added? So this is a strong acid with a very low pH. So when you add water to it, the amount of HCl is going to be less because it's diluted. It will still give you a full amount of H+, but compared to the previous concentration, it is less concentration. I'm going to give it to you in numbers. So if I have 0.10 molar of HBr, which is a strong acid, it's going to give me the exact amount of H+. If I have a diluted concentration of HBr, it is going to fully ionize, but it's going to give me less H+. So the pH here is going to be less than the pH of a solution of this one. So that's the question. Because we're going to get less amount, less amount of H+, the pH is going to be more for this new solution. And that's it.